So today I would like to welcome the director of the Danish Space Institute, Eigil Fils Christensen, who is visiting Italy today. Welcome, Eigil.
Thank you very much.
You are directing the Danish Space Institute. Tell us a little bit about what you do.
Well, I'm directing it, but it's an institute that comprises a lot of different fields. We are a small institute, about 130 people, but we engage in nearly every aspect of space research, from the Big Bang in astrophysics to the black holes, and also in the solar system, planet exploration, and also the Earth's physics, and looking into the Earth from the outside is one of our main objectives.
You and your institutes are very well known for the Danish satellite Ørsted, nominated after the Danish physicist really going into magnetic fields. Can you say a little bit about that?
Yeah, I can. It's let's see, it's about 20 years ago now that I was asked if I was interested in leading a Danish effort, scientific leading a Danish effort in that respect. And I was at that time division head in the geophysics department of the Danish Meteorological Institute. But my experience was in magnetic fields and the interaction between the solar magnetic field, the heliospheric magnetic field, and the Earth's magnetic field, measured by ground-based measurements in Greenland, which I set up 40 years ago in Greenland. So I had a big background in magnetic fields and how you can measure it and what it means, because magnetic fields is something that is very unique, because it both describes something that is happening, something of very much importance. It's the thing that is governing, for example, the visible aurora that you know about. But it also, if you measure it, it tells you about something that happens deep in the Earth's core, because the main magnetic field comes from there. I had no experience in that, but I was accepting to lead a Danish effort to do the best ever magnetic observations of the Earth by satellites. And we were happy to have a team in Denmark comprising a lot of talented young people that had some new ideas, because we knew that we had to produce a satellite that cost maybe 10 times as less than the NASA mission. So we could not do that by just using traditional methods, so we had to, our team people had to invent new methods to do that.
I have been told that Ørsted is still sending signals to the ground. How long has it been up there?
It has been up there since '99, so that's 13 years now, and that is something that we hope that it can continue until at least summer, because then the next satellite mission that is now sponsored by or paid by ESA is going up. It will consist of a much more ambitious mission consisting of 3 satellites to measure the Earth's magnetic field even more precisely than Earth. But we hope, and that is something that is very important in physics and also in all other kinds of science, that we have an uninterrupted time series, because that really tells us something that we didn't know. So just having snapshots now and then does not tell us as much as a long time series. And one of the instruments on the Earth satellite is still working. We do not know the orientation of the satellite anymore, because the star imager, which was one of our basic contributions to international space science at that time, has been blinded by the radiation in space. That's quite natural. It was only designed to live for 2 years, so now it has been living for 13 years, so we are very happy about that. But we still get the total magnetic field and without the orientation, and we hope that we can have those data. They are still interrupted by problems, because we cannot control the satellite motion. Also, it's spinning now and then, and so we have problems with having the right kind of solar angle to get power on the satellites and things like that. But we get intermittent data, and so we hope that we can continue until the swarm satellites, as we call them, the mission is up.
You already talked a little bit about this mission, the Swarm satellite. Is there any other missions that is currently on its way that you want to tell us a little bit about?
Well, there are many missions that we are, but talking about again our competence in star imager, that's Professor John Jørgensen. He has been on he is on many satellites at the moment, but the most exciting one to me is the one that was launched last year. That is NASA satellite Juno, that is going to Jupiter. It will measure also not the magnetic field around the Earth, of course, but the magnetic field around Jupiter. And Jupiter has a very, very strong magnetic field and a very strong electric-magnetic interactions. And so that is really something that I look forward to see the results from that mission, which will give some very, very new observations of what is happening.
Is that the first time we will have, let's say, a detailed map of the magnetic fields of another planet in the solar system?
No, there has been mappings of Jupiter before, or measurement, not mapping, and I'm not quite sure that we can call it a mapping, but we also have measurements around other satellites, Saturn and things like that. So it's not new in that sense. There's also a mission on the way to Mercury, which is very interesting because we do not really know if Mercury's magnetic field comes from a core, like fluid core, like we have on the Earth. Jupiter's magnetic field is of completely different origin because Jupiter is a gas planet, so it's not a solid kind of like planet. So there are so many things with different aspects, so I could not say that one or the other is more important because everything has its own aspects and is challenging.
As we talked a little bit about before, one of the reasons we are asking these questions is because we are involved in a mission to the moon in the Google Lunar X Prize competition. Have you heard anything about that competition before today?
I've heard that there was a competition, but I never really investigated what it was all about because I mean, my background is the science and not really the kind of exploration in that sense, the technological exploration. But I admire those that are keen on doing such things, because I think that is something, I mean, fantasy, imagination, both in science and also in technological drive. I think it's very important for humanity, because that is the thing that drives this civilization forward.
Many thanks for your help.